Hello everyone and welcome to another session. In this session we're going to be doing several things. Number one, we're going to briefly review the Beaver Creek example. I know it's something that we've looked at time and time again, but the key point here is quite simply that we will be doing we will be looking at new material. Specifically, we'll be looking at solving problems using computer programs. Instead of doing it manually and through graphing, like we've done, we're going to revisit an old problem, and we're going to solve it using both QM for Windows and Microsoft Excel. In our last session, you should have downloaded both programs. You should have both programs available to you. And this will become important from today to have both of them available. Because in the future, from now, we will regularly be solving problems of this nature using the computer programs. If you do not have them, if you are not following along and attempting to solve problems while watching the videos, it will be very important to succeed in this class. Okay, in the second half of this class, solving problems like this will be critically important time and time again. So hopefully everybody's very clear on that. Let's begin. The Beaver Creek example is one that we've looked at repeatedly. It involves a Native American tribe manufacturing two products from specialized labor and specialized clay. I will briefly review before we move on to some of the more advanced solutions that we've seen so far, before moving into our computer solutions. So, the Beaver Creek Company is a small crafts operation run by a Native American tribal council. The company employs skilled artisans to produce clay bowls and mugs with authentic Native American designs and colors. The bowls sell for $40 and the mugs sell for $50. The two primary resources used by the company are special pottery clay and skilled labor. They have 120 kilograms of clay available and 40 hours of labor. A bowl requires 1 hour of labor to produce and 4 kilograms of clay. A mug requires 2 units of labor and 3 kilograms of clay. Given these limited resources, the company wants to know how many bowls and mugs to produce each day to maximize profit. So this is a very simple two-variable, two-constraint problem. We see here our objective function. It's a maximization, so max Z, we're trying to maximize profit. Z is profit. Max Z equals 40x1, where x1 is bowls, plus 50x2, where x2 is mugs. That gives us this straightforward objective function. When we're doing problems like this, when we're solving with computer programs, one of the key points is that we want time and time again to make sure we're very careful in translating from natural language to equation format the questions given to us. Solving the problems becomes very easy because we're using the computer to do that for us. However, using or formatting the problems becomes much more difficult as the problems get increasingly complex. That's something we have to be aware of when we work through problems of this nature. They have 120 kilograms of clay available and 40 hours of labor. So these are limitations. We only have this available, which tells us right away that we have two limitations in this situation. We have limited clay and limited labor. So our next equation becomes this. Our objective function is subject to two limitations. The first, we only have 120 kilograms of clay. The second, we only have 40 hours of labor. So now we have to go in and look at how much to produce each product. A bowl requires 1 hour of labor to produce and 4 kilograms of clay. A mug requires 2 units of labor and 3 kilograms of clay. Translating that into our equation format, and this should be very easy because we've done it again and again, we get this situation. So this is our basic, properly formatted equation. Max C is equal to 40x1 plus 50x2, where x1 is bowls and x2 is mugs. Subject to, for x1 plus 3x2 is less than or equal to 120. 1x1 plus 2x2 is less than or equal to 40. Both of these situations allow us now to move to the next step, which is graphing the problem. The graph in this situation represents all our possible manufacturing choices. Any point on this graph represents a choice. And that point where it corresponds to the y-axis is how many bowls to produce. Where it corresponds to the x-axis is how many bowls, and y-axis how many mugs. So that's what we have here. Our next step is drawing in our constraint lines. I've done that here. The first one, if we allow x2 to equal 0, x1 is equal to 30. If we allow x1 to equal 0, x2 is equal to 40 for constraint number 1. That is the topmost line. We repeat that one more time. If we allow x2 equal to 0 with constraint number 2, x1 is equal to 40. And if we allow x1 equal to 0, x2 is equal to 20. All of this should be very easy and very clear at this point because we've solved this problem many times. We've done a lot of graphing at this point. So here we have these two situations, these two constraint lines. The first line represents all places where labor or clay is fully used. C2 represents all points where clay is fully used. If it is above C2 but below C1, we have enough clay but not enough labor. If it is above C1 but below C2, we have enough labor but not enough clay. And where it is below both lines, we have both enough labor and enough clay to proceed. So we have three possible optimal choices, A, B, and C, as we've indicated here. A, we've found visually. C, we can find visually. B, we have to find mathematically. A becomes, as we see here, 0, 20. C becomes 30, 0. B we have to find mathematically, which I do here. We take both equations, C1 and C2, and we have to equalize them. To equalize them, I multiplied equation 2 by the number 4. And we get 4x1 plus 8x2 is equal to 160, and we subtract. 3x2 minus 8x2 is minus 5x2. 120 minus 160 is minus 40. x2 is equal to 8. We substitute 8 into C1 or C2, and we get 1x1 plus 2 times 8 equals 40. 1x1 equals 40 minus 16. X1 is equal to 24. Taking this information and plugging it into point B, we get 24x1 plus 8x2. Now we multiply each of these three optimal points by our objective function, and we do that to find our optimal choice. In the first one, if we manufacture no bowls and 20 mugs, we make $1,000. If we manufacture 24 bowls and 8 mugs, we make $1,360. If we make 30 bowls and 0 mugs, we make $1,200. So our optimal choice is found at point B, manufacturing 24 bowls and 8 mugs, which gives us $1,360. That is what I've done here. To maximize profit, Beaver Creek should produce 24 bowls and 8 mugs to maximize profit at $1,360. All of that information has been gathered here for us to look at in one section. The only part that's missing, because I've full screened this, is the last line that says $1,360. So this is the problem solved to completion. It was a relatively straightforward problem. It was relatively easy to solve because it was a two-variable, two-constraint problem, and it's something we've looked at time and time again. There was nothing tricky or complicated about this question. However, that won't necessarily be the situation moving forward. It's not always going to be this simple. We have two constraints and two decision variables in this question. In the future, we may have 3, 5, 10 decision variables. 2, 4, 20 constraints. We are not limited. However, solving problems like that manually in the manner we've just done is exceptionally difficult. So what we're going to do instead of solving manually is we're going to use computer programs to solve for us. That's what we're going to do now. So the first way we're going to solve is we're going to open Microsoft Excel. Here we have a basic Microsoft Excel worksheet. All I did was I clicked File and New. That's all I've done so far. Now, we've opened a new spreadsheet. We're going to title it, just for comprehension's sake. So we'll call this the Beaver Creek example. Next, we're going to come down here and we're going to write down products. We're producing two products in this situation. The first is bowls, the second is mugs. Now what we do next, this is where we enter our objective function information. If we remember, the objective function is max z equals 40x1 plus 50x2. So in this situation, we're going to write profit. Bowls is 40. Mugs is 50. This is where it's critically important to properly translate from natural language. All we're doing in this situation is writing in what we've translated. If we translate well, this is no problem. If we make a mistake, everything from here will be incorrect. So we have to be careful when translating from natural language. Once we've done this, we're going to go down one more. We're going to mention our resources. The first, we'll make this a little bit bigger. The first resource we're using is clay. The second, labor. And I guess over here we'll mention a third section, which is total available. This is where we are essentially entering our resources, our constraints. Now, clay we know is 4 units of clay for a bowl. Four units of clay for a bowl, 3 units of clay for a mug, and we have 120 units available. This information we got from translating naturally the natural language into the mathematical equation format. We come down here and we know a bowl is 1 hour of labor. Oh. Small mistake was made here. Bowls, mugs. Now we know a bowl is 1 hour of labor, a mug is 2 hours of labor, and we have 40 hours of labor available. All we're doing is taking information we've found previously and we wrote into our equation format, and we're writing it into the Excel spreadsheet. That's what we've done so far. Now we have a couple other things that we need to do. The first thing that we need to do is change something that we've done so far. I did it like this because I wanted it to be easily comprehensible. However, this is not the best way to do this. So we're going to erase for now this section. We're going to move that section or that information over a little bit. We're going to move it over here right for now. We're going to make that right here available. And 120, 40. Because this section is going to be slightly different. This is going to be usage. Because what is happening is the computer is going to try different options or different permutations. It's going to do that trying to determine through brute force, through quite simply calculating every possibility, which is our perfect answer. So we're going to come down here and we're going to talk about how many we will actually produce. So to find our usage, we need to multiply the number of bowls times the clay per bowl plus the number of mugs times the clay per mug. This is a little bit confusing for now because these are currently empty. We haven't calculated it yet. This is what we're using the solver function for. So this is where we have to enter some equations in. The first equation, like I just said, is equal to the clay per bowl times the number of bowls plus the clay per mug times the number of mugs. Now right now it's going to be 0 because we're not making any bowls or mugs yet. But that will give us our ultimate amount of clay used. That's what we've done so far. So we're going to hit enter. And as I said, it will be 0 for now. But as the number of bowls and mugs changes, this usage figure will change accordingly. If we manufacture 1 bowl and 1 mug, this will become 4 plus 3, 7. But right now it's 0 bowls and 0 mugs, so usage will be 0. We're going to do this one more time for the amount of labor used, usage of labor. So the amount of labor per bowl times the number of bowls plus the amount of labor per mug times our number of mugs. And again, it will be 0 for now, but when we've determined how many bowls and mugs to produce, this number will change accordingly depending on how many we do produce. So that remains 0 for now. We have one more equation to enter. Now, before we enter that equation, we're going to come up here and very simply we're going to enter, just for simplicity's sake, less than or equal to. Less than or equal to. Because in this situation, the usage must be less than or equal to 120. We're going to enter that in the solver function. But for now, for comprehension's sake, we're going to enter it here as well. That's what we've done. So we're going to come down here, and our ultimate goal in this situation is to determine our profit. This is again where we have to understand the basic idea of profit. How do we calculate profit? Very simply, profit is equal to our profit per bowl times the number of bowls plus our profit per mug times the number of mugs. We hit enter, and right now it will be 0 because we're not making any bowls or any mugs. However, as the number of bowls and mugs change, our profit will change accordingly. For right now, though, it remains 0. So what we've done so far is we have come in, we've taken all of our key information from the natural language question. We've entered it into our spreadsheet. But we haven't yet computed using the solver program, what our actual number of bowls and mugs should be. Before we do that, though, we're going to do one more thing. We're going to come over here and we're going to enter the difference. And by that I mean equals number available minus the actual usage. The reason we're doing this is we want to know how many of our resources are left over. This isn't critically important yet, but it will become important in the future. So now we do that one more time. Oh. Right now, we have 120 available. We're using 0. We have 120 left over. We do that one more time, and we come here. Number available minus the number used. And right now we're using 0, so again, it will be the original value, 40. Okay. Now, this is everything we need to do prior to entering the solver aspect of the problem. So we've entered all of the relevant information. We've entered the 3 key formulas here that are reliant on the number of bowls and the number of mugs produced. What we're going to do now is we're going to enter the solver function. And this is important because this is what will determine how many bowls and how many mugs to produce given the information we provide to it. So our first thing is we have to set our ultimate objective. In this case, our ultimate objective was maximizing profit. Where do we find maximizing profit? In cell B14. So we click this. Oh, B14, done. We know we're trying to maximize. If we were trying to minimize, that would be possible. But in this situation, we're trying to maximize. Next, by changing variable cells. What we're doing here is entering what the computer will run permutations of. The computer runs possibilities. It calculates possibilities. It does that by saying, manufacture 0 bowls, 0 mugs. How much profit? Manufacture 1 bowl, 0 mugs. How much profit? Manufacture 1 bowl, 1 mug. How much profit? Etc. It will continue doing this until it determines the maximum profit, because we've told it maximum right here. So we have to change which cells. What cells is the computer figuring out? It's figuring out B12 and B13. Done. B12 and B13. So we click here on cell B12 and we drag down here to cell B13, because this is what the computer is changing. The last thing that we have to do is we have to enter our constraints. What is our first constraint? The first thing we have to do in our first constraint, this is where our constraints we enter, and we've got our constraints over here. So we add constraint number 1. And that is the usage, which is right here, D7, must be less than or equal to the total available, F7. If it is not, this is impossible. We cannot have a situation where we use more resources than the total that are available. So very simply, we click Add. We do that one more time. Our usage of labor must be less than or equal to, we can change that, but in this situation, less than or equal to the total available. We've entered both our constraints, so we click OK. Now, very simply, we're going to make this simplex LP. For our purposes in this program, it will always be simplex LP. So what I'm going to do now is I'm going to click Solve. When I click Solve, the computer will run every possibility of bowls and mugs, starting at 0 and 0, continuing until these constraints are disobeyed. It will continue until we've used 120 kilograms of clay. It will continue until we've used 40 hours of labor. Then it will examine all of those possibilities and it will choose the one with the maximum profit, because that's what we've told it to do here and here. So we click Solve. We have found a solution. All constraints are satisfied, meaning we haven't broken any of the rules we've given the computer. Optimality conditions are satisfied. We have optimized our ultimate goal, which is profit. We click OK, and we see that we have solved this problem. What we solved manually before, using graphing techniques and algebraic principles, the computer has done the same. It's also found the exact same answer. We should manufacture 24 bowls and 8 mugs, which will give us a profit of $1,360. That is how we use Excel. We're going to be doing this again and again. If you don't understand perfectly today, that is relatively understandable. It's our first time doing it. But I hope you try to solve this on your own rather than just watching, because it does make it a little easier to comprehend. So this is solving our basic Beaver Creek example in Microsoft Excel. We're going to do one more example now. We're going to do the same example, but we're going to solve it in the second program. That's what we'll do here. I've already opened it. This is QM for Windows. Hopefully you've downloaded it, because if you are just watching, instead of trying to complete, this is much more difficult. So here we are, QM for Windows. I'm going to click on File and open a new one. Oh, sorry. The first thing I have to do is click on Module, and this is where we choose our different situations. This is a linear programming problem, so we click on Linear Programming. Then we open a new file. Very simply, this is what comes up. So the first step, Beaver Creek. How many constraints do we have? How many variables do we have? This means before we enter, or before we come into QM, we have to have translated from natural language the problem into equation format. In our situation, we have 2 constraints and 2 variables. We're trying to maximize. Done. If we had 3 constraints, we would change it here. If we had more variables, we would change it here. But in this situation, it's 2 and 2. We could do a minimization, but in this situation, it's a maximization. So this isn't overly important. This is just simply names. So we click OK. And what we have here is our basic format. Now, every time we do this, we're going to change our headings so that it's easier to understand. It's not necessary to solve, but it is necessary to understand. So our first one, X1, we know is, in this situation, bowls. X2 is mugs. We're trying to maximize if bowls generate $40 in profit and mugs represent $50 in profit. So this line here is where we write our objective function. Maximize bowls at $40 and mugs at $50. That is, right here, our objective function. Max z equals 40x1 plus 50x2. Our first constraint is clay available. Our second constraint, labor available. We know that a bowl is 4 units of clay. A mug is 3 units of clay. So 4x1 plus 3x2 is less than or equal to 120. This is our constraint equation. 4x1 plus 3x2 is less than or equal to 120. Labor available, we have 1x1 plus 2x2 less than or equal to 40. Done. Once we've entered all of this information, and again, QM is significantly easier to use sometimes, not always. But with these simple problems, it is generally easier to use. So we're trying to maximize if it's $40 per bowl and $50 per mug. Clay and labor, everything is entered appropriately. We come up here, and on the taskbar, we click the Solve button. And what that does is produce this table. Our solution, 24 bowls, 8 mugs is our optimized production choice, which will generate $1,360 in profit. Quite simply, we've solved the problem accordingly. This dual value for now is not important. Everything else should be very clear right now. Hopefully this is clear. I'm going to leave you with one practice problem that we will review next time, but it is important to you to solve in order to complete the attendance quiz. Thank you everyone for listening. I'm going to put the next problem on the screen. And leave you with this. It will be relevant to your attendance quiz. So here is a problem that we've solved already. You should have this information available to you. From there, plug it into both programs, Excel and QM, and please complete your attendance quiz before time is up. Thank you everyone for listening. I'll leave this here until the 44-minute mark, and then I'll address you again. All right, everyone. Thank you for watching. Thank you for listening and watching, hopefully participating. This question is relevant to your attendance quiz, so hopefully you're able to complete it. We'll continue next class or next session. Have a wonderful day. Goodbye.